Is the divine creator hidden within the heart of a galaxy in the cosmos? The James Webb Telescope has recently unveiled the initial true depiction of a Whirlpool Galaxy, evoking a sense of peering into the countenance of the divine. The grandeur and magnificence are awe-inspiring, and this cutting-edge telescope has once more surpassed any previous observations with these unparalleled images. Galaxies stand as the celestial marvels of our cosmos. The grandeur and elegance of these immense assemblages of stars and planets verge on the unbelievable. When we gaze at galaxies like the Waggon-Wheel Galaxy or the Whirlpool Galaxy, it's challenging to attribute these formations to mere chance. The geometric intricacies, the vibrant hues, and the diversity of galaxies appear to be a manifestation of a divine blueprint. The James Webb Space Telescope is currently presenting us with a renewed view of some of the most enchanting galaxies in the universe, showcasing them in unmatched quality and beauty. Take a look at this stunning galaxy. The Whirlpool Galaxy is 27 million light-years away from our Earth. Hubble has already enchanted us with his images of this galaxy, but Webb sets new standards with his brand new images. The viewer of these images is literally drawn into this galaxy like a celestial painting, its spiraling arms spread out and ring after ring. This galaxy tells us a story of billions of stars being born and passing away in the play of time. The glowing red mainly comes from the older stars in the galaxy. These stars have a lower surface temperature and appear reddish because they shine mainly in the red and infrared parts of the electromagnetic spectrum. Some of the fascinating red structures are also formed by hydrogen gas, which is ionized by the radiation of hot, young stars and then returns to its neutral form. The radiant yellow shows us areas of active star formation. These areas are called HII regions by astronomers and consist of young, massive stars that are very hot. These stars radiate intensely in the blue and ultraviolet part of the spectrum. They appear yellow because their radiation is scattered by gas and dust. These areas can be found everywhere in the spiral arms where many new stars are being born. The kaleidoscope spectacle of colors and shapes was first discovered by Charles Messier, an 18th-century astronomer. The Whirlpool Galaxy is therefore also known among experts as Messier 51a. If you look up at the night sky, you can spot it with a good telescope in the constellation of hunting dogs near the somewhat better-known constellation of Boötus. Messier's telescope in 1771 was not yet good enough to even come close to recognizing the full splendor of the galaxy. It was not until William Parsons recognized the unique spiral structure almost 100 years later. The galaxy is unique in many ways, as it not only shows us a magnificent spiral arrangement of stars, but also its interaction with the neighboring dwarf galaxy, NGC 5195. It was most likely the dance of the two that deformed the Whirlpool Galaxy and gave it its characteristic appearance. For astronomers, the galaxy is still one of the most fascinating objects in the universe. The James Webb Space Telescope has been overwhelming us with image after image since its launch in summer 2022. Named after James E. Webb, the former administrator of NASA, it is one of the most impressive telescopes ever built. This telescope is not only technologically superior, it represents a milestone in international collaboration between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. The JWST was developed to push the boundaries of astronomy and provide even deeper insights into the universe. At the heart of the JWST is its 6.5-meter primary mirror, which consists of 18 hexagonal segments made of gold-coated beryllium. This impressive mirror collects the incoming light and directs it to the telescope's various scientific instruments. One of these instruments is the Near-Infrared Camera, or NIRCam for short, which was specially developed to capture infrared light. It has 10 sensors that cover a broad spectrum of light from visible light to the near-infrared. The NIRCam plays a crucial role in controlling and focusing the primary mirror. The mid-infrared instrument, or MIRI for short, operates in the mid to long infrared range. MIRI is a combination instrument that includes both an infrared camera and an image spectrograph. With its deep infrared imaging capability, MIRI can reveal details of distant galaxies, nebulae, and stars that were previously invisible to other telescopes. If we want to take a look at the telescope's most exciting technologies, the near-infrared spectrograph is a must. It enables the investigation of spectral lines and chemical compositions of celestial objects. Thanks to the near-spec technology, we can for the first time precisely analyze the atmospheres of exoplanets and distant galaxies. To protect the sensitive instruments of the James Webb from the heat of the sun, the telescope is equipped with a 5-layer solar shield. It's only thanks to this solar shield that the instruments in space can be kept at the low temperatures required for infrared observations. The James Webb Space Telescope was launched into orbit in December 2021. Much further out than Hubble, the telescope orbits the Earth around the second Lagrange point. About 1.5 million kilometers from Earth, on the opposite side of the Sun, the telescope's position is ideal to have an excellent view of the universe and to work in a stable environment without the disturbing influences of the Earth's atmosphere. In just 1 year, this telescope has already delivered such astonishing images and scientific findings that scientists and amateur astronomers are beside themselves with excitement. Many years of delays and the cost explosion from the launch have already more than paid off. James Webb will give us many more breathtaking glimpses of cosmic beauty and diversity and help us to solve the greatest mysteries of modern science. There is intense star formation in the Whirlpool Galaxy, especially in its prominent spiral arms. Presumably, this galaxy is producing stars like an assembly line because it's interacting intensively with its companion galaxy NGC 5195. During this interaction, gas and dust are condensed in the spiral arms, creating ideal conditions for the formation of new stars. It's precisely here in the star, forming regions that the effect of stellar feedback arises, which scientists now want to investigate better with the help of the James Webb Telescope. Stellar feedback is a process in which the existing stars in a galaxy influence the formation of new stars. This happens through stellar winds, stellar explosions, or UV radiation. Stars continuously eject matter in the form of gas and dust into the space around them. These ejected particles can collide with neighboring gas clouds and compress them, which stimulates the formation of new stars. The other variant is set in motion by supernovae. When massive stars explode at the end of their life cycle, they eject enormous amounts of energy and matter into space, compressing nearby gas clouds and transforming them into new stars. Did you know that stars emit large amounts of ultraviolet radiation? This radiation can ionize hydrogen gas and transform it into so-called H2 regions. In these regions, the conditions are ideal for the formation of numerous new stars. The Whirlpool Galaxy is one of the best examples of these processes, and thanks to the James Webb Telescope, precise measurement data on the processes in the star-forming regions are now available for the first time. This new knowledge is of fundamental importance for the evolution of galaxies, because the feedback not only regulates star formation rates, but also influences the composition and structure of galaxies. Understanding stellar feedback is an excellent example of the interaction of stars, gas, and dust, and all the processes that shape the overwhelming beauty and diversity of the universe. Can you imagine galaxies wrestling with each other for millions of years and increasingly deforming into bizarre structures? This is exactly what happens around the antenna galaxies, NGC 4038 and NGC 4039, which are famous for their spectacular collision that resulted in a relentless gravitational struggle. The antenna galaxies are named for their long, curved arms, which resemble the shape of antenna. These sinuous structures are the result of gravitational interactions between the two galaxies. For millions of years, the galactic tongues of strife have interpenetrated and condensed clouds of gas and dust into each other, triggering a truly galactic stellar feedback loop. The result of this cosmic spectacle is a vortex of stars emerging in a bizarre dance of violence between two galaxies. Several supernovae have already been observed in both galaxies, further fueling star formation. The explosion of the old stars shoots new elements into space and further stimulates star formation. M66, also known as the Firewheel Galaxy, is another spiral galaxy of breathtaking beauty and fascinating complexity. Its structure is somewhat reminiscent of the Whirlpool Galaxy, but this one, which is also characterized by strong stellar feedback, shines more in a clear blue. In the Firewheel Galaxy, we also discover luminous regions bursting with young stars and gas-filled clouds just waiting to be condensed into stars. The energy and material produced by the countless stars in this galaxy influence their surroundings in spectacular ways. The powerful supernova explosions and radiation from the young stars ionize the surrounding gas, creating the perfect environment for new stars to form. Now, where do most stars form in the Milky Way? New stars are also constantly being born in our own galaxy, the Milky Way. Star-forming regions are characterized by high concentrations of gas and dust. There are numerous such regions in the Milky Way, including the Orion Nebula, the best-known and most visible star-forming region. There are two main ways in which stars form. In the collapse theory, part of a large gas and dust cloud complex collapses under the influence of gravity, forming a protostar. In the trigger theory, on the other hand, existing stars or external disturbances, such as supernova explosions or interstellar shock waves, are used to compress gas clouds and trigger the formation of new stars. In the Orion Nebula, gravitational interactions and the compression of the gas are the stimulus for the formation of probably dozens to hundreds of new stars every year. As soon as stars are born, their radiation and winds trigger feedback effects on the environment, thus fueling the star spawn anew. Click subscribe now, because there will be even more impressive videos soon.